Welcome to today's episode of online problem solving sessions arranged by Math Aspirants WhatsApp groups. As you know, we have conducted around 20 problem solving sessions on various topics in the syllabus for JAM as well as NET GATE exams so far. Today, we are focusing more on the numerical answer type questions for JAM exam. As you know, JAM examination is on February 14th. I use this opportunity, use this occasion to wish all success to all JAM aspirants. We have so far conducted 20 problem solving sessions, and today's session is the 21st session. Already we have conducted one session on numerical answer type questions in one of the earlier episodes. Today we will be in continuation with that. I welcome today's resource person, Mr. Asif Navas K R, who is working as an assistant professor in T.K.M Engineering College, Kollam, Kerala. He postgraduated from Hyderabad Central University and qualified NET and JRF 2 times, and now working as an assistant professor. So welcome, Asif, and I take this opportunity to express my sincere gratitude to Asif for joining with us. Once again, I welcome all the participants to this event and hope that today's session will be really fruitful. One more thing, we are conducting a model examination for JAM in the exact pattern of JAM examination on February 10th. See, these initiatives are purely voluntary and the collective effort of many mathematics teachers and maths lovers. So I request the help from all of you to circulate the details of this examination to all the possible students groups in India, so that all those who are appearing for JAM exam can attend our model exam. So that will be a good occasion, will be really useful to assess themselves in their final round preparations for JAM exam. Those who are not attending JAM but preparing for NET or GATE, that persons can also attend this exam, because this will also help you to recollect the things. Okay, and the examination will be an all India level exam, because we have participation from almost all the states of India. And of course, we will publish a rank list after fixing some cutoff. We will publish a rank list. We will publish the rank list only after the JAM exam, in order to avoid the psychological effects to the participants. If somebody has got low mark as they expected, sometimes it may lead to some difficulties, some psychological dilemmas. So in order to avoid that, we will publish the rank list only after the JAM examination, but we will release the answer key through our all Google groups and WhatsApp groups and Telegram groups, so that they can check the questions and answers and learn those who have missed or not correct. Okay, so all the very best to all persons who are appearing for JAM exam this time, and also I hope that our initiatives will be helpful to all math students and all who loves maths. So I once again welcome all of you to this event, and over to Asif.
Thank you, sir. Good morning to you all. And today's session, we will focus on numerical type problem solving session. The most important thing is, rather than we are solving problems, you should focus on how to solve these problems very fast. So that is the important thing in today's session. So the most important thing in this session is you have to focus how to solve the problems very fastly. So in entrance level examination, JAM, NET, GATE, the important thing is we have to solve the problems in 1 or 2 minutes. So if we focus on the method that we learned, or the conventional way, sometimes it will take more than 10 or 15 minutes. So I in the previous session I told you that for each and every question, most of the question, right, like 90% questions, we can solve within 2 or 3 minutes. So there must be a hidden clue in every questions. So you have to identify that clue and try to do the problem in such a manner. Okay, and you have to focus on every areas of mathematics in the syllabus. But rather, I think you all go through the syllabus, and I think the important thing for preparing IIT JAM examination is you have to focus on more and more problems. That means you should practice problems, and now it's there is 1 week time for you to prepare more. So I think in this 1 week you have to practice uh, for for doing problems very fastly. So that is a very important thing. So even if you try to do problems in that time period, and that will help you to crack problems, even though you are good in maths or good in problem solving. The most important thing is you have to do it in very fast. So that is my advice. And so let us move to the problem solving session. I think you all go through all syllabus things. That means every subject, every topics in the syllabus. So I will directly move into the problem solving session. In this session, I have selected few problems in different topics. There may be algebra problems, real analysis problem, and vector integration, and every topic there is a few problems. Okay, so and I'm not doing more problems, but rather you have to focus the things like how to do problems very fast. So let me share my screen, and today's session is numerical type problem solving session. IIT JAM, especially I am taking only problems from previous year IIT JAM questions. So this is what if you want to shine like a sun, first burn like a sun. That's what from APJ Abdul Kalam. So I think you all are burning like sun. Okay. So now 1 week time is there, and we will, and all the best for your examination. So we will start with our first problem. So the first problem is IIT JAM 2020 question. So in this question, the sum of the series 1 by 2, 2 square minus 1 plus 1 by 3, 3 square minus 1 plus 1 by 4, 4 square minus 1 is. So here we want to find the sum. So the difficulty in numerical type problems is we doesn't have any options, right? So we have to solve this problem. We cannot use some probability tricks to find the answers. So rather we have to do the problems. So now this problem, this series can be written as 1 by 2 into 2 square minus 1 plus 1 by 3 into 3 square minus 1 plus etc. This is actually summation n equal to 1 to infinity 1 by n plus 1 into n plus 1 square minus 1. So this actually this series is you can rewrite this series as this is we know that a square minus b square is a plus b into a minus b. So you can rewrite this n plus 1 whole square minus 1 can be written as n plus 1 minus 1, that is n, and n plus 1 plus 1. So you can rewrite this. So I will tell you, if you want to find the sum of a series, and it's very difficult to find sum of series. So uh, I will tell you one type of series that is geometric series. You can find sum of the series. Second one is a very important telescopic series. So I will tell you what is telescopic series. Like if you have a series UK, this can be of the form Tk minus Tk minus 1 or Tk minus Tk plus 1. So this is another series. So uh, such series, for such series, we can find sum of the series, and there is some more method, integration method, so that few problems we can solve. So in this problem, we rewrite this series as of this. So now this series can be written as sum of two telescopic series. That is important. So telescopic series can be, we can easily find the. So this series actually we can written as like 1 by n into n plus 1 into n plus 2. You can written as 1 by 2n minus 1 by n plus 1 plus 1 by 2 into n plus 1. So how we can do this? Because you can use method of partial fraction. You take a by n plus b by n plus 1 plus c by n plus 2. So if you solve this, you will get a equal to 1 by 2, b equal to minus 1, and c equal to 1 by 2. So you can use the method of partial fraction. So this is not in the form of a telescopic series, but what we will do is we will convert it into a form telescopic series. So this is in this 1 by 2n minus 1 by n plus 1 plus 1 by 2 into n plus 1. This can be written as 1 by 2 times 1 by n plus 1 minus 1 by n. So this is somewhat like a telescopic series. 1 by 2 into 1 by n plus 1 minus 1 by n. So, so this is like, okay. So what we can do is we can write this series as sum of these two series. So series n equal to 1 to infinity 1 by n into n plus 1 into n plus 2. This can be written as 1 by 2 times sigma n equal to 1 to infinity 1 by n plus 1 minus 1 by n plus 1 by 2 times sigma n equal to 1 to infinity 1 by n plus 2 minus 1 by n plus 1. So this series actually, if you solve this series, you will get sigma n equal to 1 to infinity 1 by 2, 1 by n plus 1 minus 1 by n. This answer will be 1 by 2. So let, if you can write this series like if we want to solve minus 1 by 2, you can take an outside n equal to 1 to infinity 1 by n minus 1 by n plus. So, so we will get this series of the form is in a telescopic series, and if you solve this, you will get the answer 1 by 2. So now if you solve this, you will get the answer minus 1 by 4. So this is you can use a method of partial fraction, and the answer will be sum of this. So answer will be 1 by 4. So the important thing is here, if you get a series of this form, either it may be you can convert it into a telescopic series, otherwise it may be a geometric series, or otherwise we can use some integration techniques to find the sum of the series. There is no other methods as far as I know to solve such problem. So most important thing is we have to convert this problem into some kind of telescopic series. That is important thing. So the hidden clue in this problem is we have to change this problem in this manner, and then we have to convert it into telescopic series. So that is the thing. You know how to solve the problems, but you have to identify the method how to solve that problem. So now let us go to another problem. So in this is very easy problem. I think IIT JAM 2020 problem. Consider the expansion of the function f of x equal to 3 by 1 minus x plus 2x in powers of x, that is valid in uh, mod x less than 1 by, and we want to find the uh, coefficient of x raised to. So that means okay, so we know that this given function is differentiable everywhere in minus 1 by 2 1 by 2, because here the point of discontinuity, or point at which f of x is not differentiable is 1 and minus 1 by 2, right? So these 2 points is not in the uh, given interval. So this is differentiable everywhere, and the derivative of all order exists. So that means you can write it as a Taylor series or Maclaurin series. So Taylor series, you know that what is the Taylor series f of x.
Sir, audio is not clear.
Uh, Excuse me.
Audio is not clear, sir.
It's not clear. Can you?
Okay, Asif, you can continue. See, it may be due to some network issues of yourself. I think the audio is clear to everyone. Okay.
Okay. Okay.
Okay, sir.
Uh,
Okay. Is
Asif,
it clear?
someone has commented something in the chat box.
Okay. Okay. So, yes. So let me.
See, it will be better if you can join through your phone as well. Then you can read the comments from that.
Okay, sir. Okay, sir. Okay, let's. Minutes.
Okay. Asif, you may have to resume your presentation.
Okay. Okay, so just 1 minute. I will try to join us from my phone.
Okay, if there are any issues, you can continue like this. I will comment. If somebody has commented in the chat box, I will inform you. Okay.
Okay, sir. Okay, sir.
Okay, no problem. You can continue.
What is Taylor series? So somebody asked me what is Taylor series expansion. So, I think most of them know that what is Taylor series. So Taylor series means if the function is differentiable of all order, then the series can be represented as f of x can be represented as, or a function can be represented as with some center and center x equal to x. So that means this can be represented as f of x naught plus, that means as a like a polynomial. So f dash of x naught divided by 1 factorial x minus x naught plus f double dash of x naught divided by 2 factorial into x minus x naught all square plus etc. So this is actually the Taylor series expansion. So if you want to find out the Taylor series expansion of this, we have to use these. We have to find out f of x naught, f dash of x naught. So here we our series is in the powers of x minus 0 all raised to 4. So our x naught is 0. So we want to find such series are called Maclaurin series. So we want to find f of 0 plus f dash of 0 by 1 factorial x plus f double dash of 0 by 2 factorial x square plus etc. Right? So, so if you want to find the fourth power, what is the coefficient of fourth power in this expansion, and why? Because the Taylor series expansion of a function is unique. That means series representation is unique. So any expansion must be a Taylor series expansion. Okay. So, or a Maclaurin series expansion. So in order to find this problem, we have to find f of 0, f dash of 0, f double dash of 0, etc. But I think if you are going through like this manner, it will take a lot of time because finding the derivative of this is very difficult. Okay. So it will take a lot of time. So there may be some tricks, and you should so what I will do is by method of partial fraction, I can write a 3 by 1 minus x into 1 plus 2x of the form 1 by 1 plus x plus 2 by 1 plus 2x. So you know how to do method of partial fraction, right? So you have 1 minus x into 1 plus 2x is equal to, you can write it before a minus x b by 1 plus 2x. And if you solve this, you will get 3. If you take the numerator, a into 1 plus 2x plus b into 1 minus x. And if you put x equal to 1, then you will get a equal to 1. And similarly, if you put x equal to minus 1 by 2, you will get b equal to 2. So, so this is a method of partial fraction. You know how to do this. Okay. So, so now what I will do is, so uh, you all know this expansion, right? This expansion 1 by 1 minus x. So the expansion of 1 by 1 minus x is 1 plus x plus x square plus etc. So this is something like binomial series, and this is valid when mod x less than 1. So here our x is always less than 1 by 2. So this is valid here, right? So I can rewrite this in the form of 1 plus x square plus x raised to 4 plus etc. And this is I can write I will write here 2 by 1 plus 2x is of the form 2 into 1 by 1 plus 2x. So 2 into 1 by 1, 1 plus 2x you can write written as 1 minus 2x. So this expansion you can written as so here instead of x here minus 2x, so we can directly write this in the form of instead of x we have I think here minus 2x. Okay, minus 2x. So you can write it as 2 into 1 minus 2x plus 2x square minus 3 2 2 3 2x all cube. I think here it is plus 2x all raised to 4 etc. So now here we want to find the coefficient of this x raised to 4. So if you sum it up, here there is x raised to 4 and here there is x raised to 4. So that is the coefficient is 1 plus, okay, here there is 2 is there, 2 into 2 raised to 4, 2 raised to 4. So that is a 1 plus 32 is equal to 33. So the coefficient of x raised to 4 is 33. So, and okay, so this is the answer. And why I am using this because if you are doing problem in the conventional way, it will take a lot of time. So if you know, if you what use partial fraction and solve this in this manner, you can do it in within 1 or 2 minutes. So that is the hidden trick. So most of the case there may be a hidden trick in the given problem. You have to identify that. Okay. So the answer is 33. So so now we will move to, if you have any question you can ask me. Now we will move to the next problem. And next problem is the minimum value of the function f of xy is equal to x square plus xy plus y square minus 3x minus 6y plus 11 is. So here it is only given. We have to find the minimum value. So this is a question from analysis, real analysis, and I think it's a very easy question. So one of the, before going to the answer, we will move some theory part. So if we have a theorem, if f has a relative extremum at a point x naught y naught, and if the first order partial derivatives of f exist at this point, then then fx x naught y naught is equal to 0, fy x naught y naught is equal to 0. And these point x naught y naught are called the critical point. So this point is called a critical point. Critical point. And the theory says that means if you have some this is maybe our f of xy, then that means this will be a relative maxima, and maybe there may be relative minima. So at this point, if you take the partial derivative with respect to x, then that must be parallel to x-axis. So the derivative, partial derivative must be equal to 0. And if you take the uh, partial derivative with respect to y, then that uh, partial derivative must be equal to 0. So, that such points are called critical point, and then the relative extremum always occurs on the critical point. That is the theorem. Theorem tells us if you have a minimum value or a maximum value, that must occur on the critical point. Or maybe if you have it given a boundary, then it may be on the boundary point. So here there is no boundary points are given. So it must occur on the critical point. So there is a second partial test. So I have taken this theorem or these statements from Anton Piven's calculus textbook. So this is a very good textbook for studying calculus. So we have a second partial test. It tells us if f be a function of two variables with continuous second order partial derivatives in some disk centered at a critical point x naught y naught, then I'm calling d equal to fxx x naught y naught fy by x naught y naught minus f square xy x naught y naught. So this second partial tells us if d greater than 0 and fxx at x naught y naught greater than 0, then f has a relative minimum at x naught y naught. And if d greater than 0 and fxx x naught y naught less than 0, then f has a relative maximum at x naught y naught. And if d less than 0, f has a saddle point. And if d equal to 0, we cannot conclude anything. So this is the theory part. So from this theory part, we know that the minimum value might be occur because this is a continuous and differentiable function. This is a polynomial in two variable. So every derivative exists. Second order derivatives and third order derivatives exist, and all those are continuous. So every conditions are satisfied. So now this so the minimum value will occur on the critical point. So now let us find the critical point. So we have f of xy is this. To find the first derivative with respect to x, so you will get 2x plus y minus 3. And if you find derivative with respect to y, 2x plus 2y minus 6. Okay, so in order to find the critical point, I will equate fx equal to 0, which implies 2x plus y minus 3 is equal to 0, and fy is equal to 0 implies 2x plus 2y minus 6 is equal to 0. So these are the, if you solve this, you will get the critical point. So if you solve this, I will get x equal to 0 and y equal to 3. So this is the only critical point. Therefore, the relative extrema must be occur on this critical point. And let us check whether it's a minimum or maximum. So if you find fxx d is equal to fxx plus fyy minus f square xy. Okay, so what is fxx here? If we find the derivative with respect to x, you will get 2. This is greater than 0. And fyy is equal to 2. So fxx into fyy is equal to 2 minus, if you find fxy, you will get it is 1. So, 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 so our d becomes 3. It's greater than 0. Fxx is greater than 0. So there is a relative minimum at 0, 3. Now, in order to find the minimum value, we will substitute 0, 3 in this f of 0, 3, and you will get the answer. So, so the minimum value of this function is, so that is the answer. So what is here? So here in this question, so this is the theory part. So in order to do it very fast, you first find out critical point, and there is only one critical point, then that must be minimum. You doesn't want to check this. You just put those values in that, and you will get the answer. So, so, so you have to save time by using some calculators. So that is a question, and so the answer is 2. Now, now again one more question from Taylor series part. So in this question, we have given f of x is equal to root x plus root x plus alpha x greater than 0, and g of x is equal to a naught plus a1 x minus 1 plus a2 x minus 1 all square. So this is also a Taylor series, right? It is sum of the first 3 terms of the Taylor series around x equal to 1. So here it's not equal to 1. That means we are finding Taylor series with the center 1. So now given that g of 3 is equal to 2, then we want to find out alpha. So, solution. Now if we equate, so we know that what is Taylor series expansion. F of x is equal to with the center x equal to 1, we have f of 1 plus f dash of 1 divided by 1 factorial x minus 1 plus f double dash of 1 divided by 2 factorial into x minus 1 or square plus etc. So it's given that g of x is the first 3 terms of the Taylor series. So from this we can equate the expansion. We will get a naught must be equal to f of 1. So if you equate this, a1 must be equal to f dash of 1, and a2 is equal to f double dash of 1 by 2, that is 2a2 is equal to. So from here we got what is f of 1, f dash of 1, f double dash of. So so what is f of 1 here? If you put f of 1 plus alpha, so that is the value a naught, right? Then f dash of 1, similarly, if you find the derivative of f of x, you will get f of x is equal to root x plus alpha x. Then f dash of x is equal to 1 by 2 root x plus alpha. Then f dash of 1 is equal to 1 by 2 plus. Similarly, you will get f double dash of 1 is equal to minus 1 by 4. So a2 is equal to minus 1 by 8. So this you can easily find. Okay. Now given g of 3 is equal to 3, right? So g of 3 is equal to 3, and we can substitute this value in that g of 3. So g of 3 is equal to, actually g of x is this. There is actually g of x is this, and so g of 3 is a naught, plus a1, 3 minus 1, 2, plus a2, 3 minus 1 all square, 4. So now you this is equal to 3 given, which implies a naught is 1 plus alpha plus a1 is actually dash of 1 is a1, right? A1 is equal to 1 by 2 plus alpha into 2 plus 4 into minus 1 by 8 is equal to 2. So if you solve this waiting, we will get alpha is equal to 1 by 2. So if you solve this, you will get alpha is equal to 1 by 2. So this is again a question from Taylor series part. So the answer is 1 by 2. So the Taylor series is very important. Series is very important. So uh, this is a direct question. There is nothing much we have to do. So just you have to find out the if you know the definition of Taylor series, you can easily solve this problem. And this doesn't take much time. So you one of the important thing is you have to do the problem very fast. Okay. So now we will move to another question. So this is a question from vector calculus. So the question is, let us see be the boundary of the square with the vertices 0, 0, 1, 0, 1, 1, 0, 1, oriented in the counterclockwise sense. Then the value of the line integral over c x square y square dx plus x square minus y square dy is. So, so this is a line integral, and in the conventional way, if you want to do this problem, first we want to parameterize this 0, 0. So this is a square, right? 1, 0, and 1, 1, 0, 1. And we have a positive oriented square. So if you want to do line integral in conventional way, you have to parameterize this curve C1, C2, C3, C4, and you have to integrate. Integral over C is equal to integral over C1. You have to parameterize this line plus integral over C2. Have to parameterize this line plus C3 plus C. So if you do it in conventional way, it will take a lot of time. So if you have a question like line integral, you must always think about a theorem. The theorem is called Green's theorem. So you might have heard about Green's theorem. So most of the questions in IIT JAM integral line integral questions, most of them we can do it by using Green's theorem. If you do by using Green's theorem, then you can easily find the answer. Otherwise, it will take a lot of time. So Green's theorem tells us let R be a simply connected plane region whose boundary is a simple closed. You have to check whether the given curve is closed or not. Okay. Simple closed curve and piecewise smooth curve C oriented counterclockwise. If f of xy and g of xy are continuous and have continuous first order partial derivatives in some open set, then this is the important part. This is the important part. Integral over c f of xy dx plus integral over plus g of xy dy. This is equal to integral over double integral over r g of x dou g by dou x minus dou f by dou y in dA. Okay. So we will use this theorem and we can easily find the answer. So here given f of xy is equal to, given f of xy is equal to x square y square, and g of xy is equal to x square minus y square. So if you find the first partial derivative with respect to fy is 2x square y, and gx is 2x. So now look at me here. So our curve is a square, right? Curve is a square. So our link integration 0, 1. So this is a simple closed curve, and this is our region of integration R. Now this is a square, therefore our limits are rectangular limits, rectangular region. So if you want to integrate this, so by Green's theorem, integral over C, uh, integral over C x square y square dx, x square y square x square y square dx plus x square minus y square dy is equal to, by Green's theorem, this is equal to double integral over R. This is my region R. Oh, gx is this 2x minus fy. Fy is 2x square, 2x square dy dx, or dx dy. So our region, so now we can easily find out the limit of integration. So if you take this strip, so limit of integration is 0 less than x less than 1. That means x can move from 0 to 1, and y also moves from this enters to x equal to 0, and y is equal to 1. So y, so the limit of y. So therefore our integral becomes integral 0 to 1, integral 0 to 1, 2x minus 2x square y dy dx or dx dy. So if you integrate this, I'm not doing the integration, you will get the answer as 0.666. So you will get this value. So if you integrate, you know how to integrate this simple function. So the answer must be. So the important thing in this question is, most of the question in vector integration, you have to check whether the given region is a closed, simple closed region. That means like this. It might be a ellipse, a square, or a circle. Then you can use Green's theorem. So that might be very easy. Okay. So the hidden clue in this question is, you have to identify this problem. You have to do this problem by using Green's theorem. Okay, so next question is another important question. This is a question from linear algebra, and let M be a matrix. This is a, I think this is a 4 by 4 matrix, and here we have to find out the determinant of 8i minus m or q. So M is a 4 by 4 matrix, and definitely 8i minus m must be a 4 by 4 matrix. In order to find out determinant of a 4 by 4 matrix, it's very difficult and time consuming. So, so there might be some tricks. You must always think that there must be a easy method to find the answer for each and every question in Java. So this is the trick. Determinant of block triangular matrix. So this is actually a block triangular matrix, right? So this is a block triangular matrix. So here 0, 0. And this must be equal to the product of determinants of diagonal blocks. So that means product of determinants of this diagonal block and this diagonal block. That is it. But we have to find out the determinant of 8i minus m all cube. And we know that determinant of a cube is equal to determinant of a into determinant of a into determinant of. So now I will write what is 8i minus m. So 8i minus m is, so if you calculate 8i means 8i is like 80000000800080. So this is 8i. If you subtract m from 8i, you will get this. You can either check it out. So now this is also a block triangular matrix, right? This is 0. So determinant of this block triangular matrix is determinant of this into determinant. Okay. So because determinant of this must be equal to 0. So so if you calculate this determinant of this is minus 1 and that is 6. So determinant of 8i minus m must be equal to minus 6. So now the problem becomes very easy. Now what is a determinant of 8i minus m cube, m all cube? We will multiply this minus 6 in 3 times. So that is minus 2. So as I told you, in this question, if you are doing it in conventional way, it will be very difficult. Not difficult, it will take more time, more than 15 minutes or 10 minutes if you do it. But if you know these results, you can find a answer in 1 or 2 minutes. So that is the advantage. So in all competitive level examination, you have to know some certain skills. Rather, you are moving. If you think that the problem takes more time, that means if the problem in conventional way it takes a lot of time, then you must realize that there might be a simpler technique to solve the problem and think about it. Okay. So, so this is the problem. This is a problem from linear algebra. And again, one more problem. And this is also a very important problem. That's why I took this problem. Let T from R7 to R7 be a linear transformation with a nullity of T is equal to 2. Find the minimum possible rank of T square. So for such questions, if you have linear transformation, nullity, and rank, there is one important result. There is some important result, uh, rank nullity theorem. So before that, one of the trick is if you have any problem related to linear transformation, such problems you have to do by using matrices. That we know that any linear transformation, there must be an associated matrix. So that makes our problem very easy. So a T from R7 to R7, the associated matrix must be a 7 by 7 matrix. So that is T10 to. So by rank nullity theorem, for any matrix M cross A, rank of A plus nullity of A is equal to n. That is dimension. So number of columns. So this result is very important result, rank nullity theorem. In every exam, there must be at least one question using you can solve using rank nullity theorem. And we will use one more result. Rank of a matrix A into B, rank of AB is always greater than or equal to rank of A plus rank of AB, rank of B minus N. So we will use these two results to solve this. So let A be the matrix representation of B by rank nullity theorem. So rank is rank of A plus nullity is given 2, and we have number of columns is 7. Therefore, rank of A is equal to. So we get rank of A is equal to 5. So what we want to do is we want to find the minimum value of rank of A. So so we have from here we have rank of AB greater than or equal to rank of A plus rank of B plus minus N. So rank of A square must be greater than or equal to 2 times rank of A plus rank of A minus N. N is 7 here. So this is greater than or equal to rank of A is 5, rank of A 5 and minus 7 which is equal to 8. So rank of A square must be always greater than or equal to 3. So the minimum rank is, so the rank of B square must be greater than or equal to 3. So the minimum possible value of rank of B square is. So in this question, I told you that if you have any question related to linear transformation, you must do it by using matrices. So if you have any linear transformation, there must be an associated matrix, a matrix associated with this. In any problem like IIT JAM, GATE, UGC NET, every exam there must have a problem related to rank nullity theorem or related to linear transformation and matrices. Okay, so that is a very nice question. So let us move to another. So this problem is a problem in group theory. Suppose G is a group of order 57. So I will tell you one thing. In algebra, you have to remember a lot of results. Okay, if you remember those results, then solving those problems is very easy. So if you do more and more problems in group theory or algebra, then only you can do it very fast, or you can memorize those results. So this is a problem. Suppose G that G is a group of order 57, which is not cyclic. If G is G contains a unique subgroup of H of order 19, then for any G not belongs to H, order of G is dash. So we want to find if G is not in the unique subgroup H, then we want to find what is the order of G. So Given that G is not cyclic, so that means G has no element of order 57. So that means if G has an element of order 57, then order of some A equal to 57, then A must generate G because order of G is. So that then A must be a cyclic group. Sorry, G must be a cyclic group. But given that group of order 57, which is not cyclic. So there is no element in G of order 50. That's for sure. And this is very important theorem in group theory, Lagrange's theorem. Order of a subgroup. I'm not stating the exact theorem, but this is the thing. Order of a subgroup or an element. Why element? Because if order of A is equal to some M, then the cyclic subgroup generated by A must have order M. So that means if A has a order M, then there G has a subgroup, cyclic subgroup of order M. So that's why if order of a subgroup divides order of a group or order of element divides order of the. So any element of G. So any element of G has either order 1 because 57 is I think 1 into 3 into this is the time factorization. So the devices are 1, 3, 90. So now H is a subgroup, right? And this is the unique subgroup of order 19. Then the identity element E must contain in H. Okay. So E must contain in H. That means element of order 1 must contain in H. So G, if G naught belongs to H, then G naught equal to E, right? Because G is equal to E, then E is the identity element that must be inside in the subgroup. So any element, so since okay, therefore this order of G may not be equal to 1 because G is outside H. Now, if G doesn't belongs to H and H is a unique subgroup of order 19, okay, then order of G must be 3. Why? Because if if G naught belongs to H, okay, and order of G is equal to 19. If order of G is equal to 19, then the cyclic group generated by G, E, G1, order of this cyclic group generated by G must be equal to 19, and this is not H because G is not in H. Then that is a contradiction to the fact that H is the unique subgroup of order 19. So the order of G may not be equal to 19. So the only possibility is order of G is equal to 3. So that is the answer. So here, this is the important thing. So we have to remember this theorem, Lagrange's theorem, and we will just prime factorize and find out the answer. So this is a question from, I think most of the question I have taken from IIT JAM 2020. Now, this is another question. Why I include this question is most questions from vector integration or vector calculus is very easy to find the answer. So that is because you must concentrate on those topics because most of the questions are straightforward or we can easily find rather than some of the questions from real analysis is very difficult to find the answer and other questions. So comparatively easier part is vector calculus. So this is a question. F is given xi plus yj plus zk is be a sphere x minus 2 all square plus y minus 2 all square plus z minus 2 all square is equal to 4. So this is a sphere of radius 2, right? So radius of sphere is 2. Now we want to find out 1 by pi double integral over. That means this is surface integral over f dot n ds. So there are two important theorems in after three important theorem in vector calculus vector integration. First one is Green's theorem. So we done a problem related to Green's theorem. Second one is divergence theorem, and third one is Stokes theorem. So there must have at least one or two questions. I think at least two questions from these three topics. Then that must be very easy. So in this question, we will use divergence theorem. So look at this. We have to find out f dot n ds. So f dot n ds is actually triple integral over the div f. So so I will define what is divergence of f. This is actually if f is equal to f of x y z is equal to f of x small f of x y z I plus g of x y z j plus h of x y z k, then divergence of f is dou f by dou x plus dou g by dou y plus dou h by dou z. So this is actually divergence formula for divergence. Find derivative with respect to x, this with respect to y, and this with respect to z, and add. So this divergence is a scalar quantity. And look at this, our condition is satisfied. So here G must be a solid whose surface is oriented outward. So here oriented outward, and n is a outward unit. So here our surface is a sphere and it satisfies the condition, and given that n is the unit outward normal to S. So all conditions for divergence theorem satisfied. And look at this function. So here f, g, h are continuous first order partial derivatives. So here f is x, g is y, and h is z. Okay. So so now what we will do is we will solve this problem by using divergence. So now let us first so this is actually equal to 1 by pi by using divergence theorem over G div f dv. Okay, by divergence. So what is div f here? Dou f by dou x is 1 plus y with respect to 1 plus 1. So the divergence of f is 3. Now divergence of f is 3, and our surface G is x minus 2 all square plus y minus 2 all square plus z minus 2 all square is equal to 4. That is equal to 2 square. Radius is 2. Therefore, triple integral over G div f dv is equal to triple integral over x minus 2 all square plus y minus 2 all square plus z minus 2 all square is equal to 2 square. This into div is 3. 3 d. So 3 is a constant. So we have minus 2 all square plus 5 minus 2 all square plus x minus 2 all square dv. So that means this integral is actually volume of the given sphere, volume of sphere. So this is equal to 3 into volume of the sphere. We know that the formula 4 by 3 pi r cube. R is 2. 2. So our answer is 32. So that is pi, and we know that 1 by pi is right, right, because here there is 1 by pi. So the answer is 32. 1 by pi is there, and pi can cancel. So this is very easy, right? So if you know what is divergence theorem, this problem you can very easily, easily do this problem. So the important thing is you have to identify that this problem can be done by using divergence theorem. So so if you when you saw a question like unit outward normal is given n is, then you must do it by only using divergence. And now this is very important problem. This is a problem in integration, real integration, and such the more in every term examination there is at least one problem uh, like this. That means I will tell you what is the idea here. So in order to find k, we want to find the value of k. We have to integrate this. So now if you integrate this, we have to integrate first with respect to x. But you know that integral e raised to x square dx cannot be integrable. It's not very easy, right? So and given our limit is 0 less than y less than 1, y ranges from 0 to 1, and 2y less than x less than. So this is the given. So in such problems, we will use change of order of integration. Why? Because you cannot do in this order, because here e raised to x square. So what we will do is we will change order of integration. So in every jam examination, there might have one question related to this topic. And now we will change the limit. So first I will draw the limit of integration. So region is bounded by 0 and 1. Y is bounded by 0 and 1. So y equal to 0 line. That is this line. So this line is y equal to 0 line. And y bounded by y equal to 1. So y equal to 0 and y equal to 1. So this is y equal to 1. Right? And also it is bounded by here it is bounded by x equal to 2 line. So this is 2. This is x-axis and this is so x equal to 2 line. And it is bounded by x equal to 2y. X equal to 2y or y equal to x by 2. So that is right. That is this equal to 2y or y equal to x by 2. So this is bounded by So now, now our region of integration is so now what is our limit of integration? So this is our region of integration. This is our region of integration. This is our region of integration. Now, in the first limit, it's taken. We have taken a horizontal strip, right? So this strip. So it moves from 0 to 1. Y ranges from 0 to 1, and it enters through x equal to 2y. This is the range, and it stops at x equal to 2. So what now? What we will do is uh, we will take vertical strip. Okay, so that this strip can move from uh, move from 0 to 2. So x this strip moves 0 to 2. So the limit of integration 0 less than x less than 2, and this strip enters through the limit through the a region through this line y equal to 0. So the lower bound is y equal to 0, and it stops where to this line, that is y equal to x by 2. That means y equal to x by 2. So now we will integrate this. So by change the limit, this integral must be equal to double integral over range of x 0 to 2, 0 to x by 2, e raised to x square dy dx is equal to integral over 0 to 2. So now if you integrate this with respect to x, y 0 to x by 2 dx. So I will get e raised to integral over 0 to 2 x by 2 e raised to x square into limit. If I put limit x by 2 minus 0, so this is equal to integral 0 to 2 x by 2 e raised to x square dx. So now what I will get is if you integrate this now it is somewhat easier format. Erase Erasing this part. I will do the remaining portion here. So this is equal to 1 by 1 by 2 times integral 0 to 2 x e raised to x square. Now I will put r equal to x square. Now you can substitute this, which implies dr is equal to 2x dx. Therefore, dr by 2 is equal to x dx. And if you put the range as x goes to 0, r goes to x tends to 0, x equal to r goes to 0, and x tends to 2, r tends to x square, that is our range of integration between 0 to 4, and there is 1 by 2 is there, 1 by 2 times e raised to x square. This square is r into x dx is equal to er by equal to, you can take 1 by 4 outside, and if you integrate e raised to r, you will get e raised to r 0 to 4 is equal to 1 by 4 e raised to 4 minus 1. So this is the answer, 1 by 4, 4 minus 1. So we get answer 1 by 4 e raised to 4 minus 1. Therefore, the value of k is 100. So the important thing is here we have to do change order of integration. So most questions in IIT JAM, there might have a question related to this topic. You have to change the order of integration and find the integral. So, okay. So now another question is also from vector integration. This question is also we will use screens. So given that f of xy is equal to minus yi plus xj, the c is the ellipse. We have given the ellipse. Our region is some ellipse. Right? Ellipse. This is oriented counterclockwise. Then we have to find out integral over c f dot dr. So this is actually work done. F dot dr. Work done over the force F along the path C. C is ellipse. So such question, this is also a line integral. So we will use one method is you have to parameterize this ellipse. That is the conventional way, and then you can integrate this. Okay. So if you do that, it will take a lot of time. So in most of the question we can use screen. So already we discussed what is Green's theorem. So this is Green's theorem. So we will use Green's theorem. So before going to that, actually integral over c f dot dr is equal to integral over c minus I yi plus xj dot dr. Dr we will write dxi plus ey. So that is our path. We will notate r. R of t is the path. That is x of t plus I y of t. So that is the notation. So that's why dr is actually equal to dxi plus dy. So this is actually equal to integral over c minus, if you find the dot product, minus x plus x plus x. So this, now it is of the form, right? Integral of c minus y dx plus x. So, so now here we get f of xy is equal to minus y, g of xy is equal to x. Then if you find fy is equal to minus 1, gx xy is equal to 1. So we have c is a ellipse. Now we know that area of ellipse x by a all square plus y by b all square is equal to 1. You know that this area is pi into ab, right? So this you already know. So that must be useful for this. So, so what we will do is, so what we want to do is, we have to find out f dot dr, that is actually equal to double integral over r. So our region of integration is a ellipse C, and we have given so this is actually dou g by dou x minus dou f by dou y dA. So this is integral over r. R is this region ellipse. Dou g 1 minus dou this minus 1. So this is actually is equal to 2 times dA, where r is the ellipse. I think ellipse is x square by 16 plus y square by 9. So x by 4, that is x by 4 square, y by 3 square is equal to. So this is equal to integral over 2 into integral over x by 4 all square plus y by 3 all square is equal to 1 dA. That means this is equal to 2 times area of this ellipse, this ellipse. So that is 2 times, we know that area of ellipse is pi AB. So pi into 4 into 3. So this is actually 24. 24. I think you can use calculator so that you can, or you can find the value of pi 24, and that is the answer. That question is also from vector calculus. Now another question is, it is easy question. The number of elements in this set x equal to s3, and x raised to 4 equal to e, where e is the identity element of the permutation group is. So given group is S3, and you know that what is Sn? Sn is set of all permutation of n letters 1, 2, 3, etc. And you know that order of Sn is n factorial. So here order of S3 is 3 factorial, which is equal to 6. So now we want to find out how many elements in S3 such that x raised to 4 is equal to e. So the solution. So we know that if x belongs to G, x is an element in G, and G be a group such that if x raised to n is equal to e identity, then order of x divides. So here given that x raised to 4 is equal to e, therefore order of x might be 1, 2, or 4. So by Lagrange's theorem, order of an element divides order of the group. That is by Lagrange's theorem. Okay. So order of the group is 6, and therefore the order of x cannot be equal to 4. X cannot be, order of x cannot be equal to 4 because 4 doesn't divide 6. Right? So now we have to check, that means find the elements in S3 such that order of x is 1. No. The order of x is 1. There must be an identity element. So order of an identity element is 1. So their identity element must be in this set. Now you have to calculate how many elements in S3 such that order of S3 is equal to, order of that element is equal to 2. So if you calculate by using this, you will get there must have three, three elements. So total four is the answer, right? Because if you take S3, the elements of S3 is like 1, 2, 3, 1, 1, 2, 3, 1, 2, 3, 1, 2, 3, and you take the permutation 2, 3, 1, 1, 2, 3, 3, 1, 2. So that is 1, 2, 3, 1 is fixed, 3, 2, and 1, 2, 3, 2 is fixed, 3, 1, and 1, 2, 3, 3 is fixed. So if you calculate this, you will get the order of these three elements. This, these three elements must be equal to 2. So there are three elements in S3 with order. The total number of elements in this set is 1 plus 3, which is equal to 4. So this is very easy question. And so if you want to, S3 is actually isomorphic to D3. D3 means the mirror image of this triangle. So if I'm not going through that, then you can easily find just looking on this mirror images, you can identify which of the elements are have order 2. Answer is 4. Now this is another very important problem, and this is from eigenvalues and eigenvector. Okay. So the given question is, if 2y 2yz belongs to R. Just,
Sir, sir,
okay, okay, tell me. Is it clear? Tell me. Anybody have any doubt? Anybody have any doubt?
If any of you have any doubt, you can ask now. No problem. You can
Order of
unmute.
x, okay. Order of x is equal to 1 or 2. Then is definitely x raised to 4 must be equal to e. Okay, because I told you that if x raised to n is equal to, so why that order of x is equal to 2, then we already have x square must be equal to e, right? So then if you take x raised to 4, this is actually equal to x square all square. So this is e all square, which is equal to e.
sir, I want to ask with you that
Okay.
can I take identity also? Identity for 4 equals to identity, identity for 5 equals to identity also.
You to 4 equal to e. So definitely e raised to 4 is equal to e, right?
Yes, sir.
Okay, have you got it? E must be in this set. So what we can conclude, there are identity must be in this set, and also there are must be equal to 4. Is it clear? Okay, is it clear?
Sir, yes, sir. Yes, sir. Yes, sir. I got.
Okay. So if 2 yz belongs to R is an eigenvector corresponding to a real eigenvalue of the matrix 0, 1, 2, 0, sorry, 0, 0, 2, 1, 0, minus 4, 0, 1. I think this question I have done in uh, uh, previous class also, because this is very important question. That's why I choose this question again in this, because if you here, this is the eigenvector of a real eigenvalue of this matrix. So this is a 3 by 3 matrix, right? So in 3 by 3 matrix, for finding eigenvalues is somewhat difficult, because in conventional way you have a third degree you have to find out characteristic polynomial. That must be a third degree polynomial, right? Then if you solve that polynomial, you will get solving that polynomial, you will get the eigenvalues. But it's very time consuming, because finding eigenvalues, solving a cubic equation, it takes a lot of time. But if you are taking 10 or 15 minutes in an examination, that means if you take 15 minutes, you for a question, that means you cannot do more than 4 questions. So that means every question you should do within 3 minutes. So in the conventional way, if we solve this problem, it will be uh, time consuming. So what I will do is, I will give you a result. If sum of all columns of a matrix is k, then A has an eigenvalue k. Actually, it is uh, row or column, column, row or column. So sum of each element in the row or column, this column is equal to k, then A has an eigenvalue k. So for example, here what are the sum 0, 1? This is the matrix 0, 0, 1, 2 minus 4, 3. Okay. So the sum of first column is 1, second column is 1, third column also. So clearly 1 is an eigen value of of this matrix. Okay. So from the question, it is clear that there must be only one real eigenvalue. Why? Because there is no clue in the question that there is more than one real eigenvalue. Okay. So if you have such a question, you should think the eigenvector corresponding to uh, this eigenvector is the eigenvector corresponding to 1. So we got an eigenvalue, but we will show that um, there is no other real eigenvalue. So for that, in examination, you doesn't want to do all those things. You get a real eigenvalue, there is no clue in the question that there is any other real eigenvalue. So this must be the given real eigenvalue. So you can proceed with this. So in this now I will just show you that it may not have any other real eigenvalues. So we know that sum of the eigenvalues is equal to trace of the matrix. So our sum of the let lambda 1 and lambda 2 be unknown eigenvalues. So 1 plus lambda 1 plus lambda 2 is equal to trace. Trace is actually sum of the diagonal elements. Sum of the diagonal elements. So 0, 0, 3. So 0 plus 0 plus 3. This is 3. So lambda 1 plus lambda 2. Sum of these unknown, two unknown eigenvalues is 2. Now we know that in the next product of eigenvalues is equal to determinant of matrix. So this is another result. Product of eigenvalues is equal to determinant of the matrix. Now if you find the determinant of this matrix, this is very easy to find. So this is equal to 2 into the product of eigenvalue 1 into lambda 1 into lambda 2. These are the product of eigenvalue. So from here it is clear that lambda 1 plus lambda 2 is equal to 2. Lambda 1 plus lambda 2, lambda 1 into lambda 2 is equal to 2. So there is no real values here. So either you can solve it as a polynomial, or you can identify from here that there is no other lambda 1 and lambda 2 cannot be real. Any question? Any question? If you have any question, you can ask me. So is it clear? You can that means there is no, we get other two eigenvalues must be complex, because from here lambda 1 plus lambda 2 is equal to 2, lambda 1 into lambda 2 is equal to 2. So if you want to show that I can take lambda 1 is equal to, or lambda 2 equal to 2 by lambda 1. Then if I substitute in this equation, the lambda 1 plus 2 by lambda 1 is equal to 2, which implies lambda 1 square plus 2 is equal to 2 lambda 1, which implies I'm writing here lambda 1 square minus 2 lambda 1 plus 2 is equal to 0. So the roots of this polynomial must be complex. So other two eigenvalues are complex. Now we will solve that. So for solving, I will write the matrix 0, 0, 2 so that okay. So what I will do is I will take this and pasting here so that I can. So this is my question. So this is my matrix and just facing it down. So I got real eigenvalues lambda 1, lambda equal to 1. So we know that a lambda is equal to lambda into x. So here a is 0, 0, 2, 1, 0, minus 4, 0, 1, 3 into our eigenvector is given 2 y z is equal to eigenvalue, sorry, ax equal to lambda. This is our x. Eigenvalue is 1 into 2y z. So from here you will get 0, 0, 2z, and 2, 2, 0, minus 4z. 2, 2, 0, minus 4z, 0, y plus 3z. Y plus 3z equal to 2y z, right? So if you equate this from the first equation, you will get 2z is equal to 2, which implies z equal to 1, right? So I got z equal to 1, and from the last equation, we will get y plus 3z is equal to z, and I already got z equal to 1, right? Plus 1, 3z. 3z is okay. So 3z is 3 is equal to 1, therefore y equal to minus. So I got z equal to 1 and y equal to minus. So now z, what we want to find? We want to find z minus y. So z minus y is z is 1 minus minus 2. So that is the answer. So in this question, the hidden clue in this question is sum of the elements, sum of each row in this matrix is 1. So you definitely look at the problems. Either at least one problem there might have such a tricks. You can find the eigenvalues. You just, if you given a matrix to find the eigenvalues, you just check it out whether all the sum of the rows of that matrix is equal or columns of that matrix is equal. If they are equal, then one eigenvalue is must be, you will get one eigenvalue, and that saves a lot of time for you. Okay, so now 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 I will do a problem. So this problem, this is very easy problem and direct problem in differential equation. So actually this is a very direct problem. So we can do it very easily. So for doing such problems, this is actually, you can return it is of the form. I'm taking derivative d square plus 4d plus 4 of y is equal to 0. So this is a homogeneous equation, differential equation with the constant coefficient. So that means d square y means second derivative of y. 4 times dy means second derivative of first derivative of y. 4. So this is my equation number 1. Now in order to find the solution, first we want to find the auxiliary equation. I hope you all go through these topics, so that's why I am only. So auxiliary equation is, so we will replace this by some m square plus 4m plus 4 equal to 0, which implies if you solve this, you will get m equal to minus 2 minus 2. So these are the two roots. And look at this root is repeated. And one of the important thing is this question is very easy, but it will be, such questions are time consuming, so you should do it very fast. Okay, so the solution, if you have a solution of ODE, y of x is equal to it's a repeated root. So C1 e raised to minus 2x plus C2 x e raised to minus 2x. C2 x e raised to minus 2x. So from this we got this as a okay. Okay, tell me if you have any doubt.
Asif, we
Uh,
can, our time is almost over. We can wind up with this problem. I think we can have a short discussion also.
okay, so this might be the last problem. So we can do it. So now we can phi of 0 is equal to 2. So if I substitute this, we will get 2 is equal to C1 plus C2 into 0. So 0. So it's English C1 equal to 2. Now there is one more equation, y dash of 0 is equal to 0. So y dash of 0 is equal to 0, which implies 0 is equal to, okay, so first I will find out what is y dash of x. So this is actually is equal to minus 2 C1 e raised to minus 2x plus C2 into derivative of this x into e raised to minus 2x uh, into minus 2 plus e raised to minus 2x. So, so if I substitute this, I will do it very fast. 0 is equal to C1 we already know. So minus 4 plus C2 into this becomes 0, 0 plus 1. So C2 you will get 4. So my equation you will get y of x is equal to 2 into e raised to minus 2x plus 4x into e raised to minus 2x. So this is the solution. Now if you find y of log 2, you will get the answer. I am just writing the answer 1.193. So this is the last problem. So there is a the time is almost over. And so this is one of the questions. So you just work it out if you have any problem. This is, so now winners are not those who never fail, but those who never quit. So keep on trying, and all the best for your examination. Thank you.
Okay, thank you, Asif.
Thank you,
Thank
sir.
you very much. Thank you very much for joining with us. Now, so dear participants, we had so far conducted 21 sessions on different topics for JAM. I hope that if you watch and practice all these sessions, certainly you will be able to score a good rank in your JAM examination. And okay, here Siddhi Biswas is asking a question in the chat box. In multiple choice question, there is no negative. In multiple choice questions for JAM exam, we have negative marking. And for in multi-select type as well as numerical answer type, there is no negative marking. So will it be in any way affect the ranking? So I think the answer is it won't affect you. So you can attend multiple select and a numerical answer type without any fear for negative marking. And in the first 30 questions, you have to be very careful because otherwise you will lose the marks that you have obtained if you mark a wrong answer. So that is not the case with multiple select type and as well as numerical answer type. But be careful, because if you are writing a wrong answer, then there is nothing, no advantage with that. So, but you can try it, no problem. If you have enough time, you can do it, I think. And one more thing, we are having a model examination for JAM exactly in the pattern of JAM exam on February 10th, Wednesday from 7 to 10 p.m. You can attend that, and also you can share this information with your friends so that they can also join with us. The examination is purely free. Now the time for discussion for today's session. So once again, I thank Asif for being with us. Now, dear participants, you can ask your questions or you can comment here your opinion about the class. Yes. Please unmute your mic and video and keep on your video and you can interact. Yes.
Hello.
Yes.
Yes, yes.
Sir, I'm Sri Lakshmi, third year BSc Maths student from Malabar Christian College, Calicut, Kerala. And the session was very much beneficial. Got a lot of ideas to do problems in an easier way. Thank you so much, sir.
Thank you. Thank you, Sri Lakshmi. Others?
Hello,
Hello,
sir.
sir.
Yes.
Hello. Good afternoon, sir.
Yes.
I am Nayantara from Providence Women's College, Calicut. The session was very nice. Sir's explanation, it was very good. ഞങ്ങൾക്ക് നല്ലൊരു റിവിഷൻ കൂടി ആയിരുന്നു. So thank you so much for the class.
Okay. Thank you, Nayantara. Others?
Hello, sir. I'm Arya Prasad from Vimala College, Thrissur, Kerala. The session was very helpful and it helped us a lot for the final round preparation. Thank you, sir. Thank you so much.
Thank you, Arya Prasad. Any others?
Hello, sir.
Yes.
I'm Ms. Dept from Paru College, Kollam. Session was really effective as it helped to recall many results and helped to know the easiest way to approach such problems. Thank you very much, sir.
Thank you, Nusaibat. So, Asif, shall we wind up here?
Yes, sir.
I think. Okay. So once again, I thank Asif and also wish all the participants a great success in the forthcoming exams. Thank you, everyone. Okay, let us wind up here. Thank you.
Thank you, sir.